Hello everyone, my name is Michael Adekola and today I'll be doing a presentation on the breast cancer dataset for INF30030 Business Analytics, and I will be going through the steps we used in our group to achieve our final results. The business objective for this assignment is to predict the likelihood of a reoccurrence of cancer in patients. For this, we've built two models using the decision tree and the random forest. I will now move on to the R Studio to run through the codes we used. Here in RStudio, I've installed a few packages and loaded them onto the RAM, such as the R path for the decision tree and the random forest, and also the mice package for which I think is a fantastic tool for imputing our data sets. So I've loaded the data set as well, and I've named the variable calc, and we can see there's 286 observation of 10 variables in there, and we'll just run through the codes I used to explore the data. So we can see from when we downloaded the data set from the UCI data, the website, they had no column names, and I've in my code I have inserted the column names. I've also changed the strings to factors, and I have also replaced the question marks as NA. We'll have a look at the head, and we can see there are all factors. We look at the summary, and we can see immediately there's one NA in the breast quadrant, and there's 8 missing numbers in the node caps. I created 10 graphs and plotted them on a grid to visualize our data set against the target variable, which is the class. We'll have a look at that now. And straight away we can see the variables against the class variables. We can see the age and the breast quadrant are following a very normal distribution, and we can see the highest age with recurrence is between 40 and 50 years of age, and we can see the degree of malignancy. We can see the higher the degree of malignancy is, the more the increase in the likelihood of recurrence. I will use the sums to check the missing values again, and we can see, just as confirmed before, we have missing values in node caps and breast quadrant. Now I'll be using the mice package to impute the dataset, because I think it gives us more precise estimate, because it runs some algorithms to give us an estimate to the true values of the missing data. And we can see, after iterating 5 times, we can see it uses logistic regression for the node caps and polynomial regression for the breast quadrant. If we had missing values in the age, which is a categorical data, we would be using something like a predictive mean matching, which is really good algorithms. I will proceed straight to imputing the data set with the value from the mice package, and we can see now that we have no missing values. Before we build our model, I think it is very good to split the data set into training and test sets, and we'll do that just now. And we can have a look at the proportion of the training data and the test data, and we can see that there is no huge difference between both, so there is enough randomness in the data set. Now we'll build our model, and we will run the class variable against other variables to predict the model, and we'll have a look at the tree using the fancy R plot. We can see from our tree that the majority class is the non-recurrence event, colored in green, and the recurrence event colored in light blue. We see that there's few questions that are being asked. The degree of malignancy is equal to 1.1 or 2, and the probability of the root node is 0.71. If the degree of malignancy is 1 or 2, it will move on to the next question, the tumor size, and it will ask for the age before it gets to the final question, the final decision. Next, we build our random forest model as well, and we can see the out of bag error rate is 24.5%, and we can see the variable importance based on the mean degree accuracy and the mean decrease gaining. We can see the degree of malignancy is on here, and while tumor size is here. After building our model, it is essential to evaluate the model to see how accurate they perform against the test data. So the first model we'll be evaluating is the decision tree, and we will do that just now. So we can see the confusion matrix, and we can see we plotted the class against the prediction, and we can see straight away there are a few errors here. So it misclassified some data from some data points, and we'll look at the misclassified rows. Also, we can look at the confusion matrix, and we can see it correctly predicted 52 non-recurrence event but misclassified 6, as well as predicted 22 and misclassified 6. Now we'll look at the accuracy of the model. We can see it's 0.674, which is not too accurate. We can see the position, which is the ratio of true positive between the positive, it's 0.7, and we can see the recall, which is the ratio of our model correctly identifying the true positive, which is really high. We will also evaluate the random forest model, and we can see it correctly predicted 54 and misclassified 4, and correctly predicted 25 and misclassified 3. We can view the confusion matrix here as well, and the accuracy of our model is 0.6628, which is a bit lower than the decision tree model. The precision for this is 0.66, which is terrible, and the recall is a bit high at 0.93%. Building our models on the default setting sometimes often gives us low accuracy. So now we'll try to tune the hyperparameters to see if we can increase the accuracy. For this, we will be using the twofold method for the decision tree, and we've used the minimum split as 3 and the max depth as 15, and the CP we use the one standard rule to get the best CP for our model, and we will run the model now. For this tuned model, we can see our accuracy has increased to 69%, and we can see that the precision and recall has also increased. For our random forest model, we have decided to tune using the gradient boosting, the expanded grid. We are iterating between 100 and 500 trees. This is very computationally heavy, so I will run this on parallel using 8 separate R interfaces, and I will get back with the results. Now our model has finished running, and we've stopped the cluster, and we've reverted back to sequential processing. I will predict the test variables, and we'll see the confusion tree. We can see that the accuracy has increased slightly. I think the gradient boosting is really not affecting the accuracy of the model. Overall, for this analysis, we can see that the decision tree model is more accurate than the random forest. And in conclusion, Although the models did fairly well, but we would require an accuracy of zero point 0.8 and above in order for us to be able to use our model in a clinical setting. Also, I would like to suggest for further analysis or models to be built using algorithms such as the logistic regression, the support vector machines, or even the artificial neural networks. And maybe we can run our model on feature engine